Today in the U.S., there's really capacity for about 30,000 cancer treatments a year. And in the U.S., there's a need for about 300,000. And so right there you see a large gap that there's a lot of people that are today candidates for proton therapy, but there's no way to supply that need. We're building a cancer treating device which involves really a lot of high energy physics. We need to put radiation into a tumor because that radiation will then kill that tumor. Cyclotron is really the drivetrain of a proton therapy system. It is the large particle accelerator that accelerates a proton to about 2/3 the speed of light. Basically, you take water and you push a lot of power through there to rip a free proton. That proton spirals around, and once it gets to the proper speed, it then travels through some slits, travels down about a 100-foot beam line, which then makes a sharp right turn. Once it's out of the cyclotron, the proton wants to expand, it wants to emit. And so there's all these magnets in this beam line, just keep that beam positioned down that pipe as it's traveling through. And then enters a 3-story gantry, which will rotate around the patient.
Basically, when the proton runs out of energy, at this final point, it collapses, and that's where your treatment happens.
We want a proton to stop inside the tumor and then pull an electron from that tumor cell and create water inside the tumor, so you're killing that cell.
Proton therapy is different than typical radiation treatments, which just blast straight through the body. Instead, we can set how deep we're going to go and cause less collateral damage to the remaining tissue.
People are often taken aback at the size. This is a 30-foot structure.
The challenge is trying to steer an invisible beam down a line and trying to make sure all the equipment is coordinated and timed within a quarter second.
These systems are using about $1 million a year in power. You're essentially trying to mass produce a building and put the device inside of that building.
A particular challenge we had was correlating the physics models to 3D space, and we used SOLIDWORKS 3D design tables to develop a 2D sketch to allow us to then drill the holes in the right locations and install the very, very heavy equipment in the right locations. There's about 18 miles or more of electrical wiring through the system, used to connect everything from temperature sensors to high power magnets. This controls the magnet interlocks. When we have 18 miles of cable, it's very important to keep track of every piece of cable that you have. When you look at one end, you may not know what the other end connects to. We have to hand to somebody, say, pull cables XYZ through this hole. This is beyond just maybe harnessing into a car or an item like that. This is harnesses of harnesses of harnesses. I mean, it's very large. So what's unique about SOLIDWORKS Electrical is it has a back-end database which allows us to determine connections between items, and that can be exported to cable pull lists, which we can hand to our electrical installers.
We were able to have somebody actually train our guys really quickly on what's going on, and so now we're bringing on new hires. If they know the fundamentals of schematics, they know the fundamentals of drawings in the mechanical case, we can trust the fact that they're going to pick that software up pretty quickly.
Our power supply room is here.
What we're doing is so cutting edge. You have to almost tell some guys after 60 hours or 80 hours in the office, you need to go home.
And that's our rotating gantry room.
The engineer is going to stay up until 2, 3 in the morning and work on some project because A, it's interesting, but B, it's really useful when we're done. We're all trying to make this thing happen as fast as possible.
SOLIDWORKS has allowed us to save time and money by minimizing rework on such a massive project.
We're really using SOLIDWORKS for all of that concept and design as we're going through the process. Knowing what we're doing and what it's being used for keeps all of us focused on what it is we're trying to do. It's a really immersive technology that keeps you excited and keeps you going. But then it's purposeful in what we're doing, and the fact that you know this device is going to help people.